$0. I just built this $0 ASMR video system so that you can generate lots of AI ASMR video in your local host for free, all on Autopilot. Let's take a look at the demo video here. And the best part, no code at all, just drag and drop. The template is in our community. You can just download this and import it into NN easily. If you're new here, my name is Andy, and I share easy to sell AI automation system and NN tutorial like this every single week to help you kickstart your AI agency and quit your 9-to-5 job to pursue your dream. To help you achieve your goal, we also offer a Zero to Hero NN course and a comprehensive 6-month AI agency course designed to guide you from day 0, step by step, day by day, and week by week. You'll learn exactly how to build, launch, and grow your AI automation business from the ground up with clear actions, proven strategies, and real-world examples. You can also get all our advanced and ready-to-sell templates inside our template section as well. If you want technical support, we've got you here in our community. We'll make sure that all your technical problems are solved so that you can implement our templates easily. And if you want one-on-one help getting this running, we've got you covered as well. Alright, so let's get started. Previously, we made a tutorial on how to use an on-the-cloud service to create ASMR videos. The services involved included OpenAI, Kling's Cloud API, and a Sound Effects Cloud API. Among them, Kling, Sound Effects, and OpenAI all require API usage fees, and they are not cheap. Each video basically costs around $2 to $3 to complete. Today we will teach you how to generate the ASMR videos in your local host with $0. There are two approaches. If your computer supports GPU, you can actually directly install some libraries and run them locally for free. Otherwise, you can actually rent a GPU machine from Runpod or other cloud services to run video rendering libraries. And this time, we'll do a demonstration with Runpod. And again, you can run the workflow locally for free if your computer supports GPU. So let's get started. First, log into Runpod, go to the pod service. Okay, and then you can choose to deploy a new GPU machine. Pricing depends on the strength of the GPU. For example, a basic RTX 3090 may cost about 0.46 per hour, or you could choose 4090, 5090, etc. However, if you need to generate a large amount of videos, we recommend renting an H100 instance. Although the hourly rate is higher, using a 4090 or 5090 might take 20 to 30 minutes per video, while the H100 can finish in under 10 minutes. So the average cost per video is much higher. If you are generating videos at scale, we strongly recommend using a faster machine to reduce waiting time. Just turn on the machine when needed. Okay, after choosing H100, there are some configurations. First, you choose a suitable Docker template, go to Change Template and choose an official image. It must include PyTorch. The CUDA version should be 12.4.1 or above in the Docker file. Then we can go to Edit Template. You'll see two disks, Container Disk and Volume Disk. Container Disk is where your environment and downloaded models are stored. It's deleted when the machine shuts down. Volume Disk is similar to a persistent cloud drive or workspace folder. This data is preserved even if the machine is turned off. If you want to retain previously generated files, use Volume Disk. The Volume Disk will mount to a workspace folder, so anything saved in the workspace folder will be retained. If you don't care about keeping your files, you can skip this. Next is the exposed ports section. Port 8888 is usually pre-configured for Jupyter Notebook. You can also expose port 5678 to make your NN instance available through a public URL. After all that is configured, you will see instant pricing. For example, if you just want to pay as you go and you don't want to pay when you're not using it, on-demand usage is about $2.39 per hour. If you know you'll use it for months, you can actually choose a longer term plans, or if you don't mind the risk of interruption, you can select spot instance pricing like $1.25 per hour. But other users might interrupt your access if they need the GPU. So you can actually choose based on your risk tolerance and usage patterns. Okay, once ready, click Deploy Spot. and the H100 instance will launch. Click Connect to access the Jupyter Notebook interface. Then we can go to the terminal, which is a shell environment like your local terminal. If you're using a local GPU, this is the point where you begin setup. Okay, first we will install the Wan2.1 model, this one, which is the model we'll use for image to video generation. We can go to the project's GitHub page and find the git clone command in the installation section, and then we can copy that and paste the git clone command into the terminal to download folder. Once the folder is downloaded, we'll actually go into the directory. So we copy this and run this. Then we are going to copy this to run the pip install, the requirement txt file, to install all required Python packages. After all dependencies are installed, we can scroll down and find a sample script for generating an image to video file. We can actually copy that script, and then we can actually create a Python file in terminal called i2v.py, and we can paste the script into this. This script allows us to run the image to video generation for the first time. The script already includes a sample image file, this one. It will use that to generate a 5-second animation video for the sample. Once everything is pasted and saved, you can actually run the script with the command python i2v.py. Okay, the first run will take a little bit longer because it needs to download the corresponding model files, checkpoints, and configuration files. So after it's done, you'll see a file called output.mp4. We can download that and then we can watch it. Okay. So it is a 5-second animated video generated from the input image for the sample. So once the video is ready, we'll need to modify the i2v.py script a little bit. Because now we want the script to dynamically change the input image or prompt to generate a new video each time. Okay, so we'll first take out the current script and put it into ChatGPT and ask it to convert it into a dynamic script. We can copy that. Then we can actually paste to ChatGPT. So we can actually ask ChatGPT to help us to convert the above script into a command line script so that we can actually call the Python i2v.py file with a specific prompt and different images as well to generate the video. Okay, so we can start. So this script will allow us to call Python i2v.py dynamically and generate a new video each time based on different inputs like the prompts and image URL. Once it's ready, we can actually copy this and then go back here and paste it here to our i2v.py file. Next, we go on to install MMAudio. We can go to the GitHub repo. You'll find an installation section. First, we need to install some prerequisite libraries. Our current Docker file includes only Torch and not Torch Vision, and it's also missing Torch Audio. So we first need to install the Torch Audio library. Okay, we can put it here. And be careful with the part that says CU118. You actually need to change that according to your CUDA version. For example, in our Runpod environment, the CUDA version is 12.4.1, so we need to install the CU124. Okay, once those libraries are installed, our next step is to start our NNN server. Normally, to run NNN, you just run the npx NNN command, but because we need to expose the URL to receive incoming calls, we need to use webhook URL command instead, which is mainly used to input the NNN URL. Here, okay. So earlier we opened a port here, pointing to the port we need, this one. For example, port 5678. It will generate a URL. We can copy this and paste that URL into our webhook URL. Okay. You can paste it here. Then we can execute this, and then we can see the URL will come up here. We can actually directly open this URL and we will need to enter our username and password here. So this is our end-to-end interface. We can actually choose to create a new workflow. First, we can import a template here, like this. Import from file. After you choose the correct template, you can see that it's successfully imported here. The whole workflow process is very simple. It only requires 8 nodes. And before we start, we need to prepare a few things. First, the most important thing is to prepare the Google Sheet template. This is where we do the configuration. In the new Google Sheet, you need to include the following. First, the ASMR object you want to make. Second, the texture. Third, the image URL. And then, because we are skipping the OpenAI API generation, we suggest that you can simply go to ChatGPT and then input your prompt there, and it will give you an ASMR starting image. You can then download that image and upload them to Google Drive. After uploading, in Google Drive, there's a copy link function in the middle. We can actually click copy link, this one. And then we can actually paste that link into the Google Sheet. That way your end-to-end workflow will be able to read the image. Next step, we are going to set the status to pending, and on the right hand side is the output column, and then this will become an entry for end-to-end to run later. At the same time, you can also create a second entry. For example, you may want to do another object like bury in glass texture. We can also put a photo here and set the status as pending. That's all you need. Okay, once this is ready, you also need to connect your Google Sheet credentials. We can first go to this node. We can click into the credentials. Since you already set the webhook URL earlier, we can actually go to the credential settings and just configure it. In this part, you set your redirect URL, client ID, and client secret key. So where do you get those? Just go to your Google Cloud Console and search for OAuth. You'll find the credentials page. Then on the credentials menu, we can actually select OAuth 2.0 client ID. If you don't have one yet, we can actually create a new OAuth client ID here. Okay. Once created, you can use it inside the end-to-end workflow for signing in. So you can also check out the credential setup tutorial in our community and also our other YouTube videos as well. So once that's done and authentication is complete, we can actually run this first node. Okay, so for the document, we choose the correct Google Sheet end-to-end video. And then for the tab, we can actually choose the one we have ASMR local. And we can actually set the node to pull rows with status pending. And we can actually scroll down and also enable the return only first matching row option. So we can actually execute the step and you will see the first row's data is fetched here. Okay. Next, we can have a third node, which is an edit node. This is for preparing the prompt. So we are going to prepare 2 prompts. The first one is the video prompt. We use the texture and objects field from the Google Sheet to construct a video generation prompt. Okay. This is the first prompt. You can see the result is on the right hand side. And then for the second prompt, it is an audio prompt. We'll generate an ASMR style audio description using the same object and texture from Google Sheet, like ASMR sound effects of a smooth glass texture. Okay. Once the prompts are prepared, we can execute this step. You can see 2 full prompts appear here. And the next step, we are going to download the image from the Google Drive URL. We can run this download step. We can set the operation to download, and then we can set the mode by URL. We can drag and drop that Google Sheet image URL and put it here. Okay, this is the one. And we can execute the step. And you can see the image downloaded from Google Drive. This is the first image we are going to use. Next, this is something more specific to our local end-to-end setup. Although we retrieved the image, it is actually stored in an end-to-end folder. We need to move it to our local device. So we use a node called read and write file from disk. We write the file to disk and place it in a specific location. Because we are using Runpod, everything will be in the workspaces folder, so we write the file to disk in the workspace folder. For the file name, we directly use the row number. Row number can actually be retrieved from the row in Google Sheets. Once we get the row number, the file will be stored directly in the workspace folder as tool.png file. Okay, after we execute this step, it will automatically move the image from Google Drive to this location. And this is the image we just prepared from Google Drive. Okay, so once this step is executed, the next step is to run the generate videos node. So this is a node called execute command, which is available only in local NAN. So you cannot find it in cloud NAN. And we're going to use the Python script we prepared earlier. You see the Python script is located in the workspace folder, which is called i2v.py. First, we need to set a prompt. For the prompt, we use the item from prepare prompt node and insert here. Okay, we can actually find the prompt here. And for the image, we're going to use the file name from the read or write file from this node. This is the file name, which is the most accurate path. Okay. Then for the output, since it's also in the workspace folder, we use the row number as the output file name and with a .mp4 extension. Okay, this is row number, this is .mp4. So it will automatically output to workspace/tool.mp4. We'll also set the guidance scale to 7 to ensure the video generated follows the prompt more accurately. Once this step is ready, we can actually click execute step. This execution takes longer because it is running a Python script. Depending on your GPU, it could take from 5 to 10 minutes or even up to 20 minutes. Because NAN doesn't show live execution details, if you are not sure whether it is running or not, you can actually go back to the shell script and then we can actually run the command NVIDIA-SMI. If you see memory usage on your GPU, that means the script is running in the background and you can let it finish. So let's wait for several minutes. Once it's done, you'll see the result in the output. You can also go back to the workspace folder here, or the folder you specified. You can find a .mp4 file here. It's generated here. You can actually download this and check it here. And you'll see this is the video generated. Okay, nice. Now we can actually go back to the workflow. The next step is to generate the audio. So this is another execute command node in NAN. Earlier we also tested using the command line. We are using the same approach. We'll call workspace-MMAudio-demo.py file. And this time our video is 5 seconds long, so we need to select a duration. And for the video, we'll go back and use the video path from the previous step, which is the workspace folder, using row number.mp4 as the file path. So this is our input video path. Okay. Then for the prompt, we'll use the audio prompt. So go back to prepare prompt node and grab the audio prompt called prompt sound. We can place it in the audio prompt field. Okay, then the output folder will be something like workspace/row number_final. So the output will go into workspace/to_final. All right. Once everything is ready, you can execute this step to run the Python script. Similarly, if this is the first time running the script, it will take a little bit longer to install required files. After that, each run should take around 30 to 60 seconds. Once it's done, you'll see the standard output and no execution errors. We can actually go back to workspace folder and you will find a new folder called to_final. Inside this will be two files. One is the .mp4 video, another is an audio file. You can actually download this mp4 file to preview. So this is a video with the sound. After that, we can go back to the workflow. The final step is to update the Google Sheet record. So make sure you have selected the correct Google Sheet document and tab name. We can actually check here. Okay. So for column to match on, we will use row number. Okay. And we will use the row number here from the Google Sheet note and drag here for matching the correct row. Then for the status field, it's then updated to completed. Okay, for the output path, we'll use the video path we generated earlier, workspace/row number _ final. So you can actually execute a step. And after that, you can see the results automatically updated in the Google Sheets here. You can see the output path and the status is completed. Okay, so everything is ready. So the entire workflow is now complete. As a final reminder, since this is using AI models to generate video, the quality of output may vary. Sometimes the result may not be ideal. For example, in a video of an apple being cut, the motion may look strange or unnatural. In those cases, you can actually improve the quality by tweaking the prompt in the prepare prompt step. You can also adjust the guidance scale to make the results more creative or better aligned to the prompt. Okay, so that's the end of this tutorial. Feel free to let me know what you think about this tutorial in the comment section below. And you can also get this template in our community. I'll see you in our next video.